All right, let's get this started. We're up to 4-2, day 1. Strange math problem, just is. But just follow the instructions. I'll help you break down the weird words. So then the words won't trip you up. We'll just focus more on the math. That's a lot of math, just like what all these words mean. So this says rewrite this function using long division. Well, okay, that's straightforward. So we got 4x divided by x minus 3. We don't really know what they want yet, but we've done long division. And this isn't even really long. So remember the rules. What times this is this. That's all you worry about. And that would be 4. So I put a 4 up there, insert parentheses, multiply, multiply. So I get 4x minus 12. Hopefully you're a creature of habit by now. You know to subtract. You go 4x minus 4x, gone. But what's nothing minus a negative 12? Well, that'd be 12. Remember, this is your remainder. So if I'm going to try to rewrite this thing, my answer would be 4. That's my answer. And my divisor, 12, my remainder over my divisor. And that's how we would rewrite it. So that's really equal to g of x. I could sneak a little g of x in there. But then they say, hey, sketch the graph, and how is it related to this? So, but how is the quotient? See, that might throw some of you like, what the heck is that? That's just another word for fraction. How does this fraction, equation, function relate to the parent function? Once again, just a sneaky way of slipping in transformations. There's a trick though. This right here is built off of this. But I'm going to write that first as 12 times 1 over x minus 3. You'll see why in a minute. And then I'm going to put the 4 on the end. And then I go, aha, wait a minute. If I know what this looks like, which we should, hopefully that's showing up. Yeah. This, remember, looks like this. With a big old ish. We're like, okay, now we need to make the adjustments based on this. That's why I rearranged this into this. If it's throwing you a little bit, that's the benefit of the next video, the example problems. You'll see it repeat itself a little bit. So we're playing some math magic on this to make it, aha, I get it. So I'm going to start with this. That right there, remember, it's going to move it left. Whoops, not right. Not correct. Right 3. So this whole thing, the center of this whole graph, is going to go 1, 2, 3. We've done these before. And then this is going to move it up 4. 1, 2, 3, 4. There's my new center. Draw my new y-axis. There's my new x-axis. And for now, I'm going to draw this red one up here, this red one there. Now, I'm going to get rid of this. It's just not, it doesn't throw you for a loop. There's where we're at, but we're not done. Why did I rewrite it? Why did I rewrite this like this? Because that 12 is saying, hey, that's going to be a vertical stretch by 12. Now, this whole thing, sketch it. This next thing I'm about to do is just sketchy. How do we take a drawing like this and make it vertically go up by a factor of 12? Very, very difficult. It's just going to come in like this. So this is going to stretch closer to the new x-axis, and this is just going to go up faster, so it's going to be closer, like by a smidge. So I'm not too worried about that, as long as you know the vertical stretch answer. But trying to sketch this is very difficult. It's just going to be barely inside. So there you go, example 1 of the pre-lesson. Okay, Last example problem in your pre-lesson. So they're going to ask you, here's a very difficult looking function, and they're going to ask you, all right guys, find the vertical and the horizontal asymptotes. It's not as hard as you think if you keep a few things in mind. First of all, remember the simple equation, we talked about it. When we look at it, we go, hey, that thing right there, x cannot equal 0, because you cannot have a 0 in the denominator, ever. So, how do you get started on these? You get started by looking at the denominator. It's right here, x squared plus 7x plus 12. We're like, oh, well, I don't really see what x can't be. Exactly, but notice, this is factorable. X plus 4, x plus 3. And by setting this equal to 0, we're actually finding out, listen carefully, what are the things x can't be? Because what plus 4 would cause this to be 0? Negative 4. So x can't equal negative 4, because that would cause this to be 0. If I plug it in there, I'd get negative 4 squared is 16. 7 times negative 4 is negative 28 plus 12. 28 minus 28 would cause the denominator to be 0. So it's like, nope. But then we also have x cannot equal negative 3. Now, I'm not going to take the time to plug it in. You can, but you'll get a 0 down here, and that's a big no-no. Now, interestingly, if I was to graph this, which it does say, I mean, we need to look at it to figure out the vertical and the horizontal asymptotes, something interesting happens. If x cannot equal negative 4, that means my asymptote is a vertical line right there. So my asymptote is actually called x equals negative 4. Now this is what x can't be. This is the asymptote's name, okay? So remember, if they say, what's the asymptote? You don't say x can't equal negative 4. You're not wrong, but they want the equation of the asymptote. That's kind of hard for students initially. But x can also not equal negative 3, so there's this little space there. And so that right there, the asymptote's name is x equals negative 3, because the graph can't cross that. So I want you to notice that we have one section to the left of this asymptote, a second section inside the two asymptotes, and a third section to the right of the far right wall. So we have to kind of figure out what the heck. Now, what I'm going to have you guys do is, instead of taking an hour of your time and graphing this all out, which will be a huge task, I really want you to go to Desmos, type this in. Now, I haven't double checked it, but when I type it in, I make sure to go this, and then I hit the divided by bar, and then I type this in, and you'll get the graph. Now, just so you know, let me pause this a second. Okay, so I erased the red, but you go to Desmos.com and type it in, and what you'll get is 3 different pieces. You'll get that, you'll get that, and then a really weird thing way up here. I don't remember the actual coordinate of that little spot, but it's way up there. So the question is, what are your vertical and horizontal asymptotes? Well, we already took care of our vertical asymptotes. They're right there. We have 2 of them. So where's there a horizontal one? Just so you know, if I have a graph, let's say here's my xy axis, and I've got this line like this, and a graph comes in and it just gets closer and closer and closer, but never touches, we would definitely have a horizontal asymptote, let's just say at y equals 2, because it's trying to touch it and it's getting closer and closer and closer. Notice we've got this parabola looking thing right here. You could say, oh, is there a horizontal asymptote right here? No, it has a minimum, but you see the difference? This just goes down and goes up, so it's got a low spot. but there is no horizontal asymptote because we don't have a graph situation that's coming near a horizontal line. It just doesn't happen, so it doesn't exist, okay? All right, again, if that free for a loop, that's why I do the example problems following this. So now that you've learned it, you've been introduced to it, maybe we'll pound that stake in the ground a little deeper.